Good morning. It is Wednesday, April 8th. I hope that you are doing well. In Algebra 1 today, you are just reviewing. So I am just going to do a short video here for you where I record just a couple of examples, one multiplication, one division, because those are the two things that you're reviewing. And then I am going to have just a short Canvas assignment for you, just like what you've been doing the past few days for me. Do be aware, I know that they said it in your Algebra 1 video, but just as a reminder, next Tuesday you are going to have a quiz in Algebra 1 over simplifying, multiplying, and dividing rational expressions. So you need to make sure that you are ready for that on Tuesday before you hit start on that Canvas quiz, that you feel good and ready for that quiz. So on this first example, you're going to hopefully notice that this is a multiplication problem. You do need to be paying attention to the symbols on your quiz to make sure that you're doing the right operation. So this is multiplication. So when we are multiplying, we just multiply straight across, top times top, bottom times bottom. But we want to first look and see if any of the numerators or denominators can be simplified or broken down. So the first thing that I notice here is that the first piece, the left side piece, doesn't appear to be a fraction. But hopefully we remember at this point that this technically is a fraction. It just has a denominator of 1. I think writing that denominator of 1 in is going to help most of you make sure that you keep things in the correct place. So as I make my way through, the first numerator, 2x minus 3, it doesn't have an x squared, so I won't need to do the long factoring. But do 2x and 3 share a common factor other than 1? Hopefully your answer was no. So we're going to leave that as 2x minus 3. This first denominator is just 1. It's a monomial, meaning a single term, so we don't simplify that. Moving to the second fraction, we have a numerator of x minus 5. Do x and 5 share a common factor other than 1? They do not, so we're going to leave that as just x minus 5. But then we get to this second denominator, and we do see an x squared there. So since this is a quadratic expression, we are going to need to factor that. So I'm going to move over here, and I'm going to work through box method on factoring that second denominator. So if I'm going to factor that, remember I always look for two numbers that multiply to be these two put together. So I need them to multiply to be negative 48, and I need those same two numbers to add to be the middle number, so add to be 13. So do you know two numbers that multiply to be negative 48 and add to be positive 13? So if you check some numbers out on your calculator, hopefully you find negative 3 and positive 16. So negative 3 times 16 gives you negative 48. Negative 3 plus 16 will give you positive 13. So if I fill in the box now, in the upper left I have 2x squared, and in the bottom right I have negative 24. Now I'm going to use that negative 3, so negative 3x, and positive 16, positive 16x in the box. And now I need to look in each row and each column for common factors. So if I look here, 2x squared and 16x, 2 and 16 are both divisible by 2, and they both have an x that I can take. If I look over here, negative 3x and negative 24, 3 and 24 are both divisible by 3, and then because this box where the arrow leaves is negative, I'm going to make that 3 a negative as well. Now if I look across, 2x squared and negative 3x, they share a common x. And then here, make sure you're thinking greatest common factor always. So the largest number that divides into 16x and 24 is going to be 8. So I can now move back over to the original problem, and I can write this in factored form. So across the top, I see that I have 2x minus 3. And down the side, I have an x and a positive 8, so x plus 8. Now, remember that when you are looking for things that you can cancel out, you are allowed to cancel vertically, which means up and down, or diagonally. So those are the two directions that you can cancel across a multiplication sign. So if we look here, I can see that I have a 2x minus 3 here and a 2x minus 3 here that will cancel out. There's nothing else that will cancel. So on top, the only thing that I have left is x minus 5. And in the denominator, I have 1 times x plus 8. So anything times 1 is itself. So that's going to stay x plus 8. So this is your simplified answer to the multiplication problem we started with. If I move to this next one, I now am looking at a division problem. So this is what I was telling you about making sure that you're paying attention to signs. Because when you have division, the first thing you need to be thinking about is the fact that we don't ever actually divide. We instead need to do keep, change, flip. So keep the first fraction the same. Change your operation to multiplication and flip over the second fraction. But now we're going to approach this just like the problem that we did before this one. So if I start in the first numerator, 2x plus 6, so that's not quadratic, it's not an x squared, but do 2x and 6 have a common factor? Hopefully your answer there is yes, they share a common 2. So we want to take that out. And if I divide by 2 there, I'm left with x plus 3. Now as I move to this first denominator, I have 2x squared plus 10x plus 12. So my first question for you there is, do all three of those terms share a common factor? Again, hopefully your answer is yes. They share a common 2. So if I take out that 2, that leaves me with x squared plus 5x plus 6. So I'm going to come back around and get that quadratic in just a second. Let's jump over to the second fraction. In the numerator there, I have x minus 4. Do x and 4 share a common factor other than 1? They do not, so that stays x minus 4. And then this denominator would stay 1 because it's a monomial. So at this point, what I want you to notice is that here we still have a quadratic that's not all the way broken down. So we're not ready to start canceling things out because we need to get that simplified as well. So again, I'm going to move over here and I'm going to set up a box for that. This time I would be looking for two numbers that multiply to be 6. And those same two numbers need to add to be the middle number, so add to be 5. So two numbers that multiply to 6 and add to 5, 2 and 3. So in the box here, I am not putting this 2 into what I'm doing. So I'm only factoring what I underlined in red. That 2 has nothing to do with it. I already took it out. So I'm going to have x squared here and 6 here. And then I will have a 2x and a 3x, which I know from my factor pair. So if I look here, x squared and 3x, what do those have in common? They have a common x. Here, 2x and 6, they are both divisible by 2. Looking across now, x squared and 2x, they have a common x. And then here, 3x and 6, they are both divisible by 3. So now, as I go back, most of this problem from the step before is going to stay the same. The only thing that's going to change is what I underlined in red. So I have 2 times x plus 3, but then this denominator is going to look different. I still have the 2 that was there, the one circled in yellow from above, but I now know that this factors to be x plus 2 times x plus 3, and then everything else is going to stay the same. Now remember, I wrote on the last screen for you that we are allowed to cancel vertically and diagonally in a multiplication problem. So hopefully you notice that you have these 2's that can cancel vertically, but we also have an x plus 3 that can cancel out vertically. So what I'm left with here on top, the only thing I have is x minus 4. And in the denominator, I have x plus 2 times 1, which would just give me x plus 2. So this is your solution. So like I said, you have a short assignment for me, a short review assignment on Canvas. You can take it up to 3 times, just like all of them that we've been doing. And then don't forget that on Tuesday, you will have a quiz in Algebra 1. Have a great weekend, happy Easter, and I will talk to you next Tuesday.